Good morning. Guten Morgen. Thank you everyone for coming on this last day today. I'm Sarah Kim. I'm Technical Business Development Manager at Koura. And today I will be talking about Koura's next generation refrigerants, enabling the industry to meet future HFC Phasedowns. So before jumping into the main topic, I'd like to briefly introduce Koura, as we recently had some changes within our company. So we are the largest producer of fluorspar in the world, accounting for more than 20% of global supply. And we use these products and our manufacturing sites to allow mine-to-market structure that ensures a secure supply chain for our customers across sectors, including refrigeration. So CLIA refrigerants have a long legacy that went through a number of corporate changes and name changes, starting with ICI, INOS, Mexichem, and 3 years ago to Koura under the parent company Orbia. So while we have been a trusted source as supplying refrigerants to the HVAC in our industry, we have been best known for our product 134A. And because of the HFC phase-down global regulations, we understand there's a need for low GWP products to meet sustainability goals. So we're in active development and providing new refrigerants and solutions. So today I'm going to talk about 2 commercially launched products and 2 development products. So our first product is CLIA 473A. CLIA 473A, it's been recently recognized by the prestigious Rack Cooling Industry Awards 2022 by winning the Refrigeration Innovation of the Year in the technology category. So it's been developed for ultra-low temperature refrigeration. As we know, R23 or 508, they have very high GWP values. And so 473A was developed to match the safety classification. So it's an A1, non-flammable, non-toxic refrigerant, and it provides 85% GWP reduction versus the incumbent refrigerant. It's available in 3 different sizes, and you can use it in applications such as high-value cold chain, pharmaceutical, test chambers, and medical. So what are the benefits of 473A and why should you select it? So there are other proposed options to replace 23 or 508 out there, but they're either highly flammable hydrocarbons or they have very high glide of 15 to 20 degrees C, which makes it very hard to adopt, and you need major system redesign to properly adopt those refrigerants. So with that in mind, 473A was developed. It has a low glide, which makes it suitable for retrofit in existing 23 and 508 systems. However, because of this glide, there is some caution needed when charging the refrigerant. So we have developed guidelines. Also, the technical team is available to support your easy transition. We did observe improved energy efficiency and capacity over the incumbent refrigerant R23. If it was found to be effective to at least minus 75 degrees Celsius, there is also an opportunity for charge size reduction, refrigerant charge size reduction up to 15%. And because we all know that there are further quota reductions, and so GWP that is very high will probably have an impact to that. And so this 85% reduction does help with the security of supply. So let's take a look at the side-by-side property comparison of 473A versus R23. So this refrigerant is a component. It has 4 components. It's a refrigerant blend mixture. And we did a simple thermodynamic cycle calculation to compare the performance. When we looked at the COP, it's comparable to R23. We also saw a 20% volumetric capacity improvement. We also have a little bit improvement or higher temperature, critical temperature, and you see that the pressure and temperatures are very similar. You can see that the liquid density is lower than R23. So along with the density and the higher volumetric capacity allows for charge reduction, like I mentioned in the previous slide. So let's move on to the next commercial product, which is CLIA 456A. So this refrigerant was developed as a replacement to 134A. And so it was important for us to develop something that has the same safety classification. So it's an A1 non-flammable, non-toxic refrigerant, which provides a 50% GWP reduction versus 134A. As the Mac auto industry were the ones to first go through the refrigerant transition to lower GWP, we developed it originally to provide a solution in the auto aftermarket. So right now it is commercially available and it's successfully servicing 134A vehicles. Although it was originally launched for Mac, it can be used in any other 134A applications, such as cold chain, chillers, or water heating applications. So we've conducted some extensive compatibility and miscibility studies, and the components of 456A are well known and known to be very stable in HVACR systems and components. It is compatible with 134A components, and we also carried out a miscibility study with a lubricant that is compatible with both 134A and 1234YF, which is the lower GWP HFO refrigerant that is used in recently launched, more recent vehicles. And you can see that it showed very good miscibility profiles. We also developed extensive technical documents and conversion guidelines to allow for easy adoption of 456A. Taking a look at the properties of 456 versus 134A, again, we developed it to be a close match in properties for easy adoption. It's a blend of 3 components. And when we did a thermodynamic cycle calculation, you can see the COP and volumetric capacity, they're almost identical. And it's a low temperature glide refrigerant, and then the properties, temperature and pressure are also very similar for easy adoption. So let's switch gears and talk about 2 developmental products, R468C and R468B. So these 2 refrigerants, as indicated by their designation number, you can see that they have the same numbers, which means they share the same components at a different component ratio, if you will. And it was developed with the applications of commercial and residential AC and commercial refrigeration in mind. However, you have to take into consideration the safety classification of these 2 refrigerants when you adopt these. So I'll start with 468C, which was developed to replace 410A. It is about an 85% reduction in GWP. However, it is a mildly flammable A2L refrigerant, so it's intended to be used only in new systems. We did a cycle calculation of 468C versus 410A. We saw a slight improvement in COP, but it's about 17% lower in capacity, which could be easily overcome using your compressor speed, for example. It does have a higher glide, so that will have to be taken into consideration if you want to optimize your system around the refrigerant. Moving on to 468B, it's a very low GWP refrigerant, below 100. So this is about a 95% reduction versus 407C, which is the incumbent refrigerant. Again, this is a mildly flammable A2L refrigerant, so it's intended for use in new systems, and you have to follow the appropriate safety standards. When we did a thermodynamic cycle calculation, you can see it's very comparable to 407C with a slightly higher glide. And then we were interested, how does 468C perform in a 410A system? So we carried out a drop-in performance analysis. Before we dig deep into the results, I do want to point out that 468C is one of the lowest GWP refrigerants proposed as a 410A replacement, 410A-like capacity refrigerant. In this particular study, we did have 10% higher charge of 468C versus 410A. With that in mind, if you take a look at the left-hand graph, which is the COP or the efficiency, and we evaluated for both cooling mode and heating mode. At cooling mode, you could see that the COP are very similar, very close to one another. But the COP and heating does look a little lower than what we expected, which I'll go into a little more detail. If you look at the right-hand side, this is the capacities. Under cooling mode, you see about 13% drop, and then heating mode about 20%, which is in alignment with what we calculated from our thermodynamic cycles. So the reason why we think we see this drop in performance in heating mode is one theory is that this system came with a TXV. And so it was set to match the 410A superheat and cooling mode. So we didn't readjust during the heating mode evaluation. So that probably have penalized the heating performance. And then, as I mentioned, 468C is a geotropic glide that has higher glide of 410A. So if you reverse your flow, that's likely going to hurt your performance, heat transfer performance as well. So with that in mind, the results were very promising, but there is room for improvement with one of the two reasons I provide and how we can accommodate for the performance loss. So with the transition into the lower GWP refrigerants, we're currently actively developing thermal solutions with sustainability in mind, even beyond the 4 products that I shared today. And decarbonization and electrification is an important vehicle to get to your net zero goals. So we are obviously working on that. So we are working on electric vehicle solutions and heat pump solutions, for example. And we continue to do our research so that we can continue to push out low GWP products to help the customers need in compliance with regulatory transitions. So that's the end of my presentation. Thank you for listening. You can contact me at my email address, or I can stick around outside a little bit if you have any specific questions for me, or you can also stop by our booth in Hall 9, booth 404. And thank you for your attention.